Hi, my name is Ali Ayub and I'll be presenting our paper, Teach Me What You Want to Play, Learning Variants of Connect 4 through Human-Robot Interaction. Recent studies in the past have shown that interactive games lead to social development. With robots becoming an integral part of our society, our goal is to create such robots that can play those interactive games with children, specifically in hospitals and care centers. But how can we create such robots that can play those interactive games? Specifically, when the child wants to change the rules of the game while playing. Deep reinforcement learning has been used to play games like chess and Go, and they've produced remarkable success against human players. However, these techniques require all the rules to be predefined and can't be used to learn the game while playing with a human. Active learning has been used to learn games through question and answers with the human, but these techniques also were only applicable for learning the predefined rules of the games. So in this paper, we use game theory to represent and learn interactive games like Connect 4 and its variants. So in this scenario, the robot first takes the image of the Connect 4 board, converts it into this matrix format, and then into the game theoretic structure. And the advantage of game theoretic structure representation is that it can be used by the robot to reason upon and learn the full concept of the win condition that was shown in the demonstration. So in this process, the robot first gets the demonstration of the win condition on the Connect 4 board, which is then converted into the game tree. Then the robot reasons upon the game tree to manipulate it, making different hypotheses. And then the manipulated game tree is then converted to the game image, which is shown into the human to confirm the hypothesis. And this is an iterative process in which the robot learns the full concept of the shown demonstration of the win condition. As an example, consider the column win condition that was shown before in column number 1. And in this case, the robot makes the hypothesis, what if all the actions of player 1 is changed into a different action? And in the game image format, that means a different column for the win condition. And by asking the human that if this image will be a win condition, the robot confirms that any column can be used as the win condition. Now, to evaluate our system, we first perform an experiment in which the Baxter robot was taught the 4 win conditions of Connect 4, and then we played 10 games with the robot in which it won all of the times by using min-max strategy, which shows that the robot learned all 4 win conditions of Connect 4. We then taught the robot 50 different patterns on the Connect 4 board as win conditions, as the variants of Connect 4, and then played 500 games with the Baxter robot through random actions by both players. And in that scenario, we showed that the robot was able to recognize all of those win conditions and learned all of them correctly. Finally, we showed that all the different question types are actually important for learning the win conditions on the Connect 4 board by removing different questions while learning the win conditions of Connect 4. Thank you.